Hello and welcome to our lesson on solving trig equations with transformations where we use calculator. Find the general solution to trig relationships given an equation or a graph. And let's get started here. We'll start with something we've seen already. If we had the tangent of x equals root 3, we know that it's positive, therefore in the first and third quadrants. We know that's root 3, opposite over adjacent, opposite, in this case all negatives. So we would say that the larger side is opposite the larger angle. That's a pi over 3 or 60, in this case pi over 3 because we're using x. And then the period for tangent is pi n. So we would say x equals pi over 3 plus pi n. Now using your calculator we can find this information fairly easily. We get inverse tan of root 3 is 1.047, and if you do the math on that, pi is 3.14, so if you divide 3.14 by 3, you get 1.47. And if we added the period on this, it would be plus pi n. All right, so our general solution then, if we wanted to use just decimals, would be x equals 1.047 plus pi n. Now, we obviously, knowing trig exact values, would rather leave it as pi over 3, but we want to make sure that you understand that this is just a number. Pi over 3 is 1.047 dot dot dot, and so that's going to be, some answers are not trig exact values, so we're going to have to get used to seeing that information. Now I want to show you a graph real quick of another way we could have done this. If I were to graph the tangent function here, we would see that at 1.047 and change, we are at y equals 1.732. Well, 1.732, that is the value of square root of 3. So there's our value there, and then we simply keep adding a period, which in this case for tangent is 1 pi, so plus 1 pi or minus 1 pi and minus 2 pi. We would get those same values. All right. So let's work with some numbers we're not familiar with and make this a little more challenging. We could look at sine and cosine and see that our trig exact values are simply numbers that can also be determined using a calculator. For instance, anything, square root of 2 over 2, 0.707, pi, 3.14. These are all just numbers, but when the numbers are not trig exact values, we were forced to use a calculator. So we want to get used to seeing these decimal forms. The rest of the lesson will deal with non-exact values. That means they require a calculator. And we'll use cosine, but we will generalize to all trig functions in class. All right, let's get to work then. We'll try to get x, and there's a lot of operations being done to it. So we'll start on the outside. We'll subtract the 5. That gives us a 2. Then we have a times 3. And when we divide 2 by 3, hopefully we notice that that value is not a trig exact value that we could get without a calculator. So in this case I need to undo cosine. I'm going to undo cosine with inverse cos. And that's what our calculator understands is the value on the principal branch. And then we'll use some information to, some understanding of what we know about the function to get it to generalize. So when I do inverse cos on the calculator in radian mode, I get 0.841 and change, so we'll write that 4 so given this information is 0.841, and then we're just going to use 3 decimal places. This equals 4 parentheses x minus 1. We can do this math, divide by 4. You can see that's what I did here. And then I'm going to add the 1. So adding 1 gives me a value of 1.210. And then a bit of a tricky thing here. We're going to take what the value is, in this case the 0.84 value, that was this angle here. We're going to do 2 pi minus that angle. That would give us our other positive value of 2/3. So that's that value there. I subtract it from 2 pi, I get this value. That's this angle around to here, 5.44. Notice 6.28 is 2 pi, so it's less than that. Then I undo the same two operations here, divide by 4, add 1, and I get this 2.36. You're going to see in the next slide when we solve this graphically that that's beyond the point of an intersection that I had gotten. So I'm going to subtract 1 period from that value. It's closer to the y-axis. So the value 2.36 works, but so does a period before or a period after. And of course, with the period being 2 pi divided by 4, that's just a pi over 2. All right. And taking this information, the 1.210 and the 0.7, in this case 90, if I round properly, those are values I should see when I do some graphing. So for instance, if I have the same equation and I set the right side in this case equal to y1 and then the left side equal to y2, I can see when these two values are equal by doing second trace 5 and then enter, enter, enter. And if you notice when you hit second trace, option 5 is intersection. We're trying to find out where these two values occur in the same place. That's an intersection. But the hardest part probably at this point is figuring out what windows to use. For x, I chose values that made sense for the period. 2 pi over 4, again, is pi over 2. Pi over 2, if pi is 3.14, half of that's a little over 1.5. So I knew I needed 1.5 to see 1 period, a little over 3 to see 2. So I chose a window of negative 0.5 to get on the left side of the y-axis, up to 3.5. For the y, I chose somewhere between 5 plus 3 and 5 minus 3. I actually went down to negative 2 so I could see the x-axis also. And I got these two values. Now if you look at these values, the one on the right makes pretty good sense. That was values I got right out of the calculator when I calculated. And then this 0.7897, that's this value here. When I did it on the calculator, I actually got this one. That was that 2.36 or whatever. So if I subtracted a period, I got a value that made sense with that intersection. So let's think about this. A lot of work on the previous slide. On this slide, if we simply take the two sides of the equation, set them equal, second trace 5, enter, 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 you'll be able to find all the solutions you need. Now let's try another one where the equation must be determined from a graph. Okay, if we're given this graph and asked where do these two equations meet, or where is there a solution, we would know that these are the points of solution. These are just a period apart, and these as well, 1 period apart. We could estimate, and we will here, but we want to know exact answers, and we're going to use what we know about creating an equation from a graph to find those with the calculator. For now, to estimate the solutions, I'd simply notice here that the period goes from 2 to 14. That's a total of 12. And that I get x equals, and I'm going to use the values 6 and 10, 6 plus 12n and 10 plus 12n. So there's my answers that I estimate. Let's verify by finding exact values using the calculator. Our first step is to find an equation, a y equals equation, and we're going to use cosine as usual. We just previously determined that 2 to 14 is our period. That makes it a period of 12. And we also know that the max is 7 and the min is down here at negative 1, so that's a total of 8. Half of that gives us an amplitude of 4, and halfway in between, if you go up 4 from negative 1 or down 4 from 7, we get 3. The B is the hard thing to find. We get that from the period. The D then, the phase displacement, we're going to use the number 2. We could, of course, use 14 or any value that's a period away from the number I'm using, 2. And then B then is going to be 2 pi over 12. You could use 360. We're going to try to stick with radians. That gives me pi over 6 and an equation of y equals 3 plus the amplitude 4. We're sticking with the cosine curve because it's easy to see its max value. We then put in our b, pi over 6, parentheses x minus 2. Using that equation, plugging into the calculator, this is going to be nice. We simply plug in y1 is this equation, y2 is 1, second trace 5, enter, 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 and we get intersection of 6 and 10.